Okay, so let's have a look at example 5. We have 1, 2, 3, 4 matrices, A, B, C, D. Part A, write down the order of the matrices. Okay, so order of A is, well, it's 2 rows by 3 columns. Order of B is, it's 3 rows by 2 columns. Order of C is 1 row by 3 columns, and order of D is 2 rows by 2 columns. B, which of these products exist? Okay, so part 1, A times B. Well, let's check the dimensions. So A is a 2 by 3, B is a 3 by 2. Do the inside numbers match up? Yes. And we may as well do part C as well while we add it. So C is talking about write down the order for the products which do exist. So the resulting matrix should be a 2 by 2 matrix because it's the outside numbers there. Part 2. Let's look at B times A. So the dimension of B was 3 by 2. The dimension of A was 2 by 3. Check, do the inside numbers match up? Yes, they do. Then that means the product exists, and the resulting matrix would be the outside number dimension. So it's a 3 by 3 answer. Part 3. B squared. Well, B squared means B times B. So what's B again? So it's a 3 by 2 times a 3 by 2. Do the inside numbers match up? No, they don't. So the inside dimensions don't match up, so product does not exist. So inside dimensions do not match up. Do not match up. So product does not exist. What else? Part 4, AC. So AC, A was a 2 by 3. C is a 1 by 3. Check, do your inside dimensions match up? 3 and 1 do not match up. So therefore, because the inside dimensions do not match up, the product does not exist. I'm gonna do some iPad magic, copy and paste. Yeah, there we go. And one more, part 5, D cubed. So D cubed is D times D times D. Okay, so dimension of D is a 2 by 2, and then a 2 by 2 and a 2 by 2. So I would do it one at a time. You can't multiply all 3 at the same time. So I'm just going to go left to right. I'm going to multiply the first 2 D by Ds, if possible. So check, do the inside dimensions match up? Yes, the inside dimensions match up. And then this resulting D squared would give us a 2 by 2 matrix because of the outside numbers. So then this really gives us D squared times D, right? We agreed that D squared was a 2 by 2. D originally is also a 2 by 2. So let's check, do the inside dimensions match up? Yes, so the resulting matrix would be a 2 by 2 matrix. It would exist, and you would also end up with a 2 by 2 matrix. Okay, part D is saying, well, actually work out mathematically the products which exist. So out of all those options, we can only work out A times B, B times A, and D cubed. So let's work out these products. So part D, let's work out A times B. So let's first substitute the matrices in. So A was 1, 2, 3, oops, make sure you have gaps between your numbers. 4, 5, 6 times, I mean, you can write a time symbol if you want to, you don't have to, it's implied. 2, 0, 5 down, negative 1, 4, 3 down as well. Okay, so this is where the chant comes in, row by column, row by column. We know we are expecting a 2 by 2 matrix because back over here we said a 2 by 3 and a 3 by 2 gives me a 2 by 2. So make sure you always check the dimensions before you multiply anything. We know we are expecting a 2 by 2 matrix. So we're expecting 1, 2, 3, 4 entries in our final answer, right? So the question is, well, what goes in those entries? Well, row by column. So row by column. So right now we've got row 1 in the yellow by column 1 in the yellow. Row 1 by column 1 gives me entry 1, 1 of my answer. So I have a 1 times 2 plus 2 times 0 plus 3 times 5. So I'm row by columning every element inside the first row and first column. So that gives me entry 1, 1 of my matrix. Next, let's row by column, row 1, column 2 of our matrix. So that answer is in the row 1, column 2 entry of our resulting answer. So we have 1 times negative 1 plus 2 times 4 plus 3 times 3. So I'm getting the numbers as the elements of each row and column, and I'm adding between everything I multiply by. So 1 by 1, and then the next one 2 by 4, and then 3 by 3, and then I'm adding them in between. Because this is row 1 by column 2, this number, whatever I multiply and add, ending up with, is row 1, column 2 entry of my final matrix answer. Okay, let's do row 2, column 1. So row 2, column 1 gives us 4 by 2, because that's the first entry elements, plus the second elements 5 by 0 plus 6 by 5. Yeah, so we have 4 by 2, the first elements, then we add the second elements 5 by 0, then we add the next element 6 by 5, and then that entry, because we're in row 2, column 1, that is the row 2, column 1 entry of our resulting matrix. And then finally, let's finish off with row 2, column 2. So we have a 4 by negative 1 are my first elements, plus 5 by 4, plus 6 by 3. And then I close off my answer with a matrix square bracket. Always remember to close off your brackets. And then that gives my row 2, column 2 entry. So evaluating that, 1 times 2 is, so 1 times 2 is 2, plus 0 plus 15 gives me 17. Negative 1 plus 8 is 7. 7 plus 9 is 16. Next we have 8 plus 0 is 8. 8 plus 30 is 38. And lastly, row 2, column 2, negative 4 plus 20 gives me 16. 16 plus 18 gives me 34. So as expected, we did end up with a 2 by 2 answer, right? And then our entries, row by column, row 1 by column 1, row 1 by column 2, row 2 by column 1, And lastly, row 2 by column 2, it gives us entry 2, 2 as well. So row by column, you multiply each of the elements one by one, and then you add them as well. So that's AB. Let's do the same thing for BA. Oh, okay, I'm out of space. Let's see if I can shrink any of this so I can get more space out of it. Whoops, let me do that again. Okay. Resize. Yep. No. Okay, hopefully this works. Resize. Oh, the B got rid of it. Oh well, I can just erase that. Get rid of that. Patch up the B. I'm gonna make this a little bit smaller. Resize. Okay. Let's do where are we up to? BA. So BA, let's write down our matrices. 2, 0, 5, negative 1, 4, 3 by 1, 2, 3, 4, 5, 6. So as we explained before, we expect, because this is a 3 by 2 and a 2 by 3, we expect a 3 by 3 answer at the end. All right. Now, in terms of communication, do you have to have this middle line back up here? No, you don't. If you understand the pattern on how to multiply, you can directly jump to the last line there. You don't have to write in the inside part. But because we're still learning on how to multiply, I will include this inside calculation for now, just to explain what's going on. But really, you don't have to if you understand what's going on. So I expect a 3 by 3. Okay, so row 1, column 1 gives me entry 1, 1, right? So row 1, column 1 is 2 by 1 plus negative 1 times 4. So that would be entry 1, 1, because that's row 1, column 1. If we did row 1, column 2, we would get entry row 1, column 2. So that's a 2 by 2 plus negative 1 by 5. So each element, and then you end up with that. Then if we did row 1, column 3, we would end up with 2 by 3 and negative 1 by 6 in the row 1, column 3 entry. Like that. Yeah? Do you see a pattern? Hopefully you see the pattern. Row by column, whichever row and column you're looking at, it's the row and column entry of your resulting answer. You multiply each element. So you have 0 times 1 plus 4 times 4 as row 2, column 1. Then you have 0 times 2 plus 4 times 5 as row 2, column 2. And then you have 0 times 3 plus 4 times 6 as row 2, column 3 entry. Lastly, row 3, column 1, 5 times 1 plus 3 times 4. So that's row 3, column 1. And then you have 5 times 2 plus 3 times 5, row 3, column 2. And lastly, 5 times 3 plus 3 times 6 as your row 3, column 3 entry. Okay, let me do a bit of resizing again. I'm out of space. Let me do this again. Resize. Yeah, that's still readable. That will do. And then, so we finish off with the answer and actually working it out. So 2 times 1 is 2, minus 4 is negative 2, Going across, 2 times 2 is 4. 4 minus 5 is -1. 2 times 3 is 6. Minus 6 is 0. Next we have 0 times 1 is 0. 4 times 4 is 16. 0 times 2 is 0. 4 times 5 is 20. And then you have 24. 5 times 1 is 5. Plus 3 times 4 is 12. So that gives us 17. 5 times 2 is 10. 3 times 5 is 15. So that together gives me 25. 5 times 3 is 15. 15 plus 18 gives me 33. And as expected, we did end up with a 3 by 3 because that was the outside dimensions, because the inside dimensions matched. And that's what we wanted to see as well. Again, this inside for calculation, you don't have to show that explicit multiplying and adding if you understand what numbers to multiply and add. I just did put it there so to help people see what numbers to multiply and add and where to put your resulting answers in. If you get it, good on you. You can just do the BA equals substitute, check your dimensions and get straight to the answer if you know where your row and columns are and which one to multiply and add by. Yep. So we have one more to go, which is part working out d cubed. I am going to add a single page. Might be easier than just resizing. So part 5 is d cubed. Okay. So d cubed, remember, was d times d times d. Let's substitute that d in. So 1, -2, -1, 3. 1, -2, -1, 3. I'm going to multiply that 3 times. Again, you should always check your dimensions. We did check it before, right? We said that all your dimensions inside was 2 by 2s, and then that became a 2 by 2, so then that became a 2 by 2, so then your final answer should be a 2 by 2. So we're going to multiply this step by step as well. So let's focus first on the first two matrices to multiply them. So I'm going to do it without all the extra working. So hopefully you'll be able to follow along as well. So let's do row 1 by column 1. So 1 times 1 is 1. Plus -2 times -1 is a +2. So 1 plus 2 gives me 3. Row 1, column 2. So -2 and -6 gives me -8. Then I have so row 2, column 1. So -1 and -4 gives me -5. So that's row 2, column 1 entry. And lastly, row 2, column 2 entry gives me a +2 plus 9. +2 plus 9 is an 11. So yes, we expected that to be a 2 by 2. So copy that down. So let's multiply the next 2 by 2. So we have first row by first column. It gives me 3 times 1 is 3. 3 plus 8 is 11. So row 1, column 2. So 3 times -2 is -6. 3 times 8 is 24. So -24, -6 and -24 gives me -30. So row 2, column 1, -5, -11 gives me a total of -16 in row 2, column 1 entry. And lastly, row 2, row 2, column 2, that's a +10 and a 33. That gives me a 43, +43. And there we go. As expected, we wanted a 2 by 2 matrix, and we got a 2 by 2 matrix because that's what we expected to get when we checked our dimensions. So one key note to take away when you're multiplying matrices is always check your dimensions before you multiply. If your numbers inside don't match, you can't multiply. If it helps you for a few starting questions, do the extra writing out explicitly what you're multiplying and adding. But if you know how to do that already, I'm happy for you to just do it in your head and write the answers over there. So finishing off with that final sentence, very, 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 very important, okay? So last lesson we said that if you add matrices, the order in which you add doesn't matter. So A plus B is the same as B plus A. But very importantly, when you multiply, that is not necessarily true. So matrix multiplication is not commutative. The order in which you multiply matrices makes a huge difference. Why? Well, even consider this example in part D. A times B, so A and B were the same matrices, right? We didn't change A and B. But A times B gave us a 2 by 2, whereas B times A gave us a 3 by 3. And clearly this 2 by 2 and a 3 by 3 is not the same matrix. So A times B is not necessarily the same as B times A, so you can never swap the order of multiplying, right? So important point number 1, cannot swap order for multiplying matrices. And key point number 2, always please check the dimensions before multiplying. Very, very, very important. In the next video, I'll show you how to type orders in and multiply in your graphics calculator. It's very much similar to adding and subtracting. And you can also test out what happens if you try to type in something which gives us no results. Like for example, b squared. If you type in b squared in your graphics calculator, it will give you a math error because it can't be done because the dimensions don't match up.